Hello class. Today what we're going to be talking about is how to graph an absolute value function, or how to graph an absolute value graph. So, to begin with, we need to realize that absolute value graphs are always going to resemble the letter V. So anytime that you're asked for an absolute value graph, or anytime that you're asked to graph an absolute value graph, it should resemble a V. And it's essentially a capital V. So when we're looking to graph an absolute value graph, what we need to first do is we need to consider what's inside of our absolute value bars. So as we recall from our first unit, what we have here are what are called absolute value bars. So what we want to do with what's inside of our absolute value bars, in this case it's x plus 3, is we want to set it equal to 0. So we're going to say x plus 3 equals 0, and we solve that, and we get x is equal to negative 3. So we know that negative 3 is something that's called our vertex for our graph. And the vertex is going to be the point of this V. So going y equal the absolute value of x plus 3. What we're going to do is, now that we have our negative 3, we know that our negative 3 is our vertex, we're going to make a table of numbers, as you recall from previously. So we make a table of numbers. We're going to make our middle number negative 3, because that's where our vertex is. And then we're going to make our, we're going to pick 1 to 2 numbers above and 1 to 2 numbers below. I'm just going to do 1 number above and 1 below. And then we substitute them into our equation. So for negative 4, we get y is equal to the absolute value of x plus 3. So we put in a negative 4. Negative 4 plus 3 is going to be a negative 1. And the absolute value of negative 1 is going to be 1. If I put in negative 3, I'm going to get negative 3 plus 3, which is 0. The absolute value of 0 is going to be 0. If I put in negative 2, I'm going to get y equal the absolute value of negative 2 plus 3, which is a positive 1. And the absolute value of positive 1 is just 1. So I have points at negative 4, 1, negative 3, 0, and negative 2, 1. So what I want to do now is simply graph these points on my coordinate plane. So I'm going to go to negative 4, 1, make a point there. Negative 3, 0, make a point there. And negative 2, 1, and make a point there. And I'm going to connect my points. And my graph should resemble a V shape centered at my vertex. Again, my vertex is negative 3, 0. Let's take a look at an example for you guys to try. So let's say that we've got y is equal to the absolute value of 2x minus 4. Go ahead and take about 30 seconds to figure this out. Feel free to pause the video if you need more time. Alright, so first thing we need to do is we need to figure out what our vertex is. So our vertex is going to be, we're going to look at what's inside of our absolute value bars, and we're going to set that equal to 0. And when I solve this, I'm going to get x is equal to 2. So now that my vertex is at 2, so I'm going to go ahead and make my table of values. I'm going to center it at 2. I'm going to go I'm going to go down 1 and up 1. So I've got 1, 2, and 3. So I'm going to say y is equal to the absolute value of 2 times 1 minus 4. 2 times 1 is 2. 2 minus 4 is negative 2. The absolute value of negative 2 is going to be positive 2. So now we're going to put in 2 in. So we're going to say y is equal to the absolute value of 2 times 2 minus 4. 2 times 2 is 4, and 4 minus 4 is going to be 0. The absolute value of 0 will just be 0. So for my y value for 2, I'm going to put in 0. And then I'm going to look at 3. So y is equal to the absolute value of 2 times 3 minus 4. 2 times 3 is 6. 6 minus 4 is 2. The absolute value of 2 is 2. So I have 1, 2, 2, 0, and 3, 2. So I'm going to now plot these points. I'm going to have 1, 2 right there, 2, 0, and 3, 2. I connect my points, and it should make a V. That's not a very good V, but it should make a V. Let's look at one example where not necessarily everything is inside the absolute value bars. So let's say we have y is equal to the absolute value of x plus 4 minus 1. So for this, we're still going to set what's inside our absolute value bars equal to 0. So that does not change. So in this case, we ignore the minus 1, and we're just looking at the x plus 4. So we're going to say x plus 4 equals 0, subtract 4, and we get x is equal to negative 4. Then we would substitute that, then we would create our table of values. So we'd say x, y, we have negative 5, negative 4, and negative 3. If we substitute negative 5 in, we're going to have y is equal to the absolute value of negative 5 plus 4 minus 1. Negative 5 plus 4 will be negative 1. The absolute value of negative 1 is 1. 1 minus 1 will equal 0. So I have negative 5, 0. Next I'm going to put in negative 4. So I'm going to say y is equal to the absolute value of negative 4 plus 4 minus 1. Negative 4 plus 4 is going to be 0. The absolute value of 0 will be 0. And 0 minus 1 is going to be negative 1. So I'll put in negative 4, negative 1. And then let's do the same thing for negative 3. Negative 3 plus 4 is going to be a positive 1. Absolute value of positive 1 is 1. 1 minus 1 is going to be 0. So I have my points negative 5, 0, negative 4, negative 1, and negative 3, 0. So, and when I plot these points, I'm going to have a point at negative 5, 0, negative 4, negative 1, and negative 3, 0. And then I make my V shape. That's going to be the graph of y equal the absolute value of x minus 4 minus 1. So remember that when you graph absolute value, A, you should always have a V. B, you need to set what's inside your absolute value bars equal to 0 and then solve it. And that's going to give you what's called the vertex. And after that, you need to pick 1 to 2 points above and 1 to 2 points below your vertex, and then substitute those in and solve them. And tomorrow we'll talk about how we can solve this on the calculator, and that should help you double check your answers to make sure that you're right. Have a good day.